Okay, let us come, like now that we know whatever we learned so far in the last class, we learned about different levels of data. NOIR, that is nominal, ordinal, interval, and ratio data, right? When you call a data set nominal, no rankings are involved, but categorical variables. Ordinal data where rankings are involved and yet categorical. Interval data where there is no zero true point, but the difference makes sense. Ratio data when we are dealing with numerical variables, but the difference makes sense, but there is also a true zero point, right? These are four different data types, that is data levels, that is nominal, ordinal, interval, and ratio. Now it is your homework to identify which data falls under which category, whether it is nominal, ordinal, interval, or ratio. That is your homework. So that you can do. Now that we have understood there are so much levels of data, so which data level is the highest level? Yes, good. So ratio data is the highest level of data, right? Highest data level. Now that we understood these are the classification of data levels, now let us come to a bigger form of storing data. How you will store data. So one way to store data is data cube. Okay. So it's a multidimensional data we want to store. Fine. So a multidimensional data, So a multidimensional data model views data in the form of a cube. Okay. So what is a data cube? A data cube is characterized with two things. What are those two things? One is dimension. Okay. And another is the, I think I forgot. Yeah. So the perspective or entities with respect to which an organization wants to keep record is the dimension. Okay. That these are just polished English statements, but you will see the example, you will understand this. So an example we will take in this scenario is the rainfall data from the meteorological department. Rainfall data from the meteorological department. Okay. So what kind of data it will have? What kind of data it will have? Any ideas? Yes, exactly. Numerical data. But will it have only numerical data? What kind of categorical data it can have? Ratio? I mean, we are not talking about the type of data level. We are talking about here how we are storing data. How we are storing data. I mean, you can store data as columns, you can store data as rows. In this class, you can see now it is a form of a matrix. Isn't it a matrix? We can count the number of rows, we can count the number of columns, right? So, and each one has a data set. Each one is a data, right? Each one represents a data, right? It's a male or a female, and which program he is studying, what is his age, what is his weight, all details about him. So each matrix point holds the data, right? Now think that on the top of this floor, there is another class going on. Now it has another matrix of data, right? And on the top of that, there is another class going on. There is another matrix of students sitting there. So that's like a data cube. Each layer, this is SODS. The top floor might be electronics. The top floor might be geoinformatics. Ecology or something like that, right? So you will see how the same scenario happens in rainfall data. So you can see the rainfall data from the meteorological department. We are recording the time. I mean, which year, how much amount of rain has happened, in which season that rain has happened, in which month, which week, and which day of the week it has happened, right? And what is the location also, like country, region, state, locality, district also. After that, you can come to city, and further you can come to district. Yes, fine. So now let us see one by one. So this example you can see in this 2D representation, the rainfall for the northeast region of India are shown with respect to different months for the period of years. Okay, what do I mean? Just see the figure here from 2005 to 2010. From 2005 to 2010, we are seeing the data set of rainfall from the month January to December. Over the period of throughout the year in different years, like 2005, what has happened? How much amount of rain? 10 mm of rain in particular area or not? Okay. In these grids, you can fill the data. In these grids, you can fill the numbers 50.2, 25.8. Okay, like that, right? Decimal data. Fine. Now we want to understand in different aspects of India, like eastern parts, western parts, northeast. Suppose we want to represent data according to times, that is the year and month, as well as the regions of a country, say east, west, north, northeast. So this is like a 2D view of a 3D rainfall data. 2D view, we are just taking slices. We are taking slices. How some of you might not understand why it is a 3D data. Now, why it is a 3D data? You can visualize this on top of, you can stack them. You can stack this on top of this, you can stack this one, on top of this, you can stack this. So the first stack is the east, then the west, then the northeast. So it's a 3D data, but we are slicing it to make it 2D data, right? Okay. Now this is the 3D view. This is the 3D view. Why I am telling you that the rainfall data is a 3D data set. Okay. You can see the month is here on the x-axis. The year is on the y-axis. Now the same, which month and in which year the rainfall has happened. Now we are treating it for different regions. That means that is another dimension. That is, maybe this is Kerala. This is maybe Hyderabad. This is maybe Bangalore. Okay, maybe this is other states, you can say MP, something like that. Okay, and you can continue with those number of states. Now, can you see? There is something more than this. This is just for India. Now you can do this for every country in the world. Okay. Now you see that when you do this with different countries, like the same thing, same 3D data, when you treat it for different countries, like for India, you are having this 3D view. For South Korea also, you will have a 3D view. For Sri Lanka and Japan also, you will have such 3D views of data, right? Now, what is a data cube? This enables us a 3D view of the rainfall data for a continent, say. Okay. So for the entire world. Now my question is how the data set looks like for the entire world. That's the idea. I mean, each country has some amount of a 3D kind of cube. Now, when you talk about the whole world, then how this looks like. So just as a visual representation, you can see this. Okay. So this is something known as data aggregation. Aggregation means you are aggregating them together. So you can see this is from South Korea. This is from India. Okay. This is from Japan and many different countries, so on throughout the world. So they are collecting each data set. They are aggregating them here. Fine. And those are further getting aggregated to a bigger form. Those are further getting aggregated to a bigger form of a data, right? This is like roll up. We are rolling the data set together in an upward fashion. So, and this data is very complex, of course. Complex, but yes, it stores all the data throughout the world in which part of the country where the rainfall happens. I mean, if you have this data set, then what you can do with this data set? By using pandas, I mean, it's just one of the tools to do data analytics. Okay. Using pandas, you can find in Kerala, in August month, in week number 2, how much rainfall has happened. Because it has all the data set throughout the world. So it has every information. Okay. Okay. But how you do that? That in Kerala, how much rain has happened? That you do by drilling down approach. You construct the whole set of this data set, this complex data set, by using the roll-up operation. This is the roll-up operation. But when you want to see a particular area information, you have to segregate data. This is known as data segregation. Okay, that means you go back. That is drill down. This is known as a drill down approach. Okay, this is known as a drill down approach. Okay. Fine. So this further brings us to data segregation. Now you understood what is data aggregation, where you collect data from different parts of the country or city, state, and gather them to make a very complex data set in such a way that full data of weather or rainfall pattern is available in that bigger data cube. Now, to understand some aspects, I mean, throughout the world, what you can do? It will tell you the climate change patterns, right? How it will tell you climate change patterns? It will tell you climate change patterns by any example in 2024, what is the median rainfall has happened throughout the world. There will be median rainfall or mode rainfall, maximum rainfall. Now in 2025, the mode has increased. The maximum rainfall has increased. What does it suggest? That means the ice is melting. The glaciers, these ice sheets are melting down, and those are causing the rainfall pattern to change and bringing more rainfall. And we are predicting more rainfall to occur in the subsequent years to come, leading to more floods and tsunamis. Okay, this is kind of so how you visualize data and you make insights of data. This is what I am telling you. Okay. Now, just having the data cube, suppose you have the data cube. This data cube you have. This is the data cube. This is the data cube you have, but this data cube you don't know what to do, and you don't know that how you can find what is the rainfall in Kerala in the month of August. I want to find the maximum rainfall in Kerala in 2024 in the month of August, in the whole month. You are not able to find. Then there is no use of this data. So you should be equipped. Once you generate too much of an amount of data, you should be equipped with techniques when to use when, in such a way that you can get insights from those data. Okay, fine. So this is known as data cube segregation. Like you can see. Suppose what was this this column? Can you remind me? Month, year, region, right? So this was month, this was year, and this was the region, right? So what happens if you take this block? If you take this block here, which was taken right now, okay, this is the 3D visualization of that. Now, if you take this block and put it over here, so what does it tell? It tells you that for a fixed year, and for a fixed month, okay, if you are selecting this block, does it mean that year you are fixing? You are fixing the year. Is it clear to all of you? You are fixing the year, right? And you are fixing the month also. What is this month? January, suppose. And this month is suppose 2010, right? This year is 2010. This is 2011, 2012, 2013. And we are taking this block. That means 2010 year is fixed and the month January is fixed, right? And what is varying? If you take this block, the region is varying, right? If the region is varying, what does it mean? It means that in the year 2010, in the month of January, what are the rainfall in different regions of the world? So when you take out this block gives you that information. I hope you are able to appreciate why we need a data cube. Okay. Suppose you did not have a data cube. Suppose you don't know the concept of a data cube before, and I will tell you this statement. This is the homework for you, that in 2010, year 2010, and the month of January, give me rainfall data of various regions throughout the world. Okay. Do you think without data cube it would be easy? No, it won't be easy, because for every state you will do the survey, and every state of the country you will gather the data, and every country you will get the data. That will be months of time. Too much amount of time it will go. So once you have stored the data in form of a data cube, easily you can do all sort of manipulations. Okay. Now can you tell me what is this H? What is this single cube represent? Okay. Huh? Yes. Yes. Fixed region. That's most important. Fixed region. Now you're fixing the region also. Like maybe you can say in which state do you want me to refer? Palakkad. Okay. In Palakkad, what is the rainfall amount? Right? In Palakkad, what is the rainfall amount? Right? So in the year 2010, in the month of January. That this small tiny block will give you the idea. Now, what is E? So your task is, after you see this slide, is to understand each of these blocks. what each of these blocks signify. Okay, what each of these blocks signify. I told you about this block and this block. You should think how what each other blocks signify. Anyone about this one? Maybe this one. Mm, no, it depends which one we are selecting. Shall we select the horizontal one? Shall we select this? Yes. Yes. So what you do is in a fixed year in 2010 and maybe in Thiruvananthapuram, okay, TVTM. In 2010 in Thiruvananthapuram, throughout the month or throughout the whole year, what is the rainfall data? So you can see how much impact it has, like how much the impact data cube has on your analysis. Okay. Since you are already doing analysis based on this data analysis, okay, we are trying to see how much is this data analysis or data analytics. Yes, it is analysis because we are analyzing based on the past data. Okay, how much amount of rainfall has happened, then we are predicting why it has happened. Okay, what led the rainfall to happen. Now based on this data, if you predict in 2026, suppose this is still 2025, in 2026 what should be this block which has not been filled yet, then you are doing analytics, you are predicting it. Okay, you are predicting it using different, based on this set of past data, you are predicting what is the rainfall going to be in the next year like. Okay, that is using machine learning techniques or different algorithms. That is like predictive analytics. Okay. Fine. So I hope this is clear. So now, now we know that how now. So okay, what is the story so far? We'll always come to the story so far section, just so that everyone is reminded whatever we have done so far before going to something new. We learned about data, what is data, right? And what kind of data measurements are there. Neuer, different levels of data measurements. What's the top form? Ratio. What is the least level? Nominal. Yes. So based on that, you are able to classify which kind of data level is nominal, ordinal, interval, and ratio data, right? And you can see in ratio data, you can do all sort of arithmetic operations. Okay, you know which data is which data level. Okay, so that's good. Then we came to data cube. Okay, we came to data cube. What is a data cube? Why it is important? Data cube is a way to store data. Okay, it's like a storing multidimensional data. Suppose storing his weight is just a single dimension data, but storing weight of every person in this university and throughout Kerala and throughout India and the whole world is a multidimensional data, and therefore you single dimension you cannot store. You have to use multi-dimension way of storing it. That's a way of saying as a data cube. So even though you are storing more dimension than a cube, which is 3D, you are still calling it a data cube. Okay, so one of my think is you could have told it data hypercube. Hypercube is something more than the dimension of the cube. Okay, I don't know if that term exists, but if it exists, it's good. Okay. Next, we'll come to data life cycle. Okay, why we are motivated to take this term as data life cycle? Any ideas? Why we are motivated to take the term data life cycle? See, data, you treat it as a life form. That's the idea. Okay, data, when you bring in data, you analyze data. You analyze data, right? You polish the data, you clean it. It's just like when you bring vegetable. Okay, what you do, you bring in the vegetable first. Will you eat it? You clean the vegetable, you keep it, you soak it, and you clean the vegetable, peel it off. You do processing on that data, right? You do the processing on that vegetable. How you do process on that vegetable? You cut it. How you cut it, it depends on you. Whether pieces, whether round shape, whether triangle or diamond shape, up to you. Okay, but this is the process you do on the vegetable. Then what you do, you further process, that is fry, deep fry, or steam, whatever, right? Then after you get the vegetable done, the food is that is known as a recipe that is done. Then you eat it. Then what you say, this is good, right? This is good, or some salt is missing. You do some analysis on that, right? So that's the way. And after that is done. The life of that food is done. So that's what in data also. What is the life cycle of a data? That is known as a data life cycle. That is known as data life cycle. Okay. So what steps a data goes through? What major turn of life events a data goes through? That is like a data life cycle. Okay. Can you tell me from here, what before going through this, can you tell me what we should do first? Hmm? Hmm. Yeah. But before that, before acquiring the data set, you should plan. You should plan whether, suppose, like, maybe I can say, let us take the example of the shopkeeper again. So the shopkeeper, if he only, there are some shops who don't take your personal data, but there are shops who take your data. I mean, they will ask your name. Through the name, they can identify whether it's a male or a female, and they ask you your number also, so that they can sell you your number. They can give you promotional messages. But there are other marketing strategies where they don't ask you anything. They just take scan the items, give you the money, you pay. Okay, so it depends on the marketing strategy whether they want that additional data or not. So they have to plan. They have to plan. So if you get those data of the customers, it is good enough, because you will know which customers in which age group come to your shop, and you can plan the products in your shop according to that age group. Okay, if suppose teenage, like age group 20 to 30 they come, then you will prefer more like noodles, more ready-made items, because in the age of 20 to 30, people are mostly busy building their careers, right? So they don't have time to cook. They don't have time to cook, and they believe in, and they don't have money also. They don't have time to cook. They don't have money also, and due to that, they can't spend food. They can't spend huge amount of money on food, right? But so therefore, they turn out to spend on ready-made items. Okay, like noodles or bread, milk, something like that, ready-made items. So those items, more in quantity he can keep, and less items such as dal, ready-made dal or something, they can keep it less, right? Because one has to cook those things. You got the idea. So you have to plan first. Okay, you have to plan which data you want. You cannot take all data you want. Okay, so the shopkeeper, what the shopkeeper will do by collecting your weight, what the shopkeeper will do by collecting your weight, that's a additional data, right? Have you ever heard a shopkeeper ask your weight after your name? No, right? So that's the idea. So the weight is a additional data term which is not necessary, so you don't need it. So you have to plan which data variable you need. Okay, so plan or design, then you build or acquire the data. Okay, now you decided that you want the customer name and the customer age and other things. Okay, then you have to plan to acquire those data sets. Okay, so in whenever a customer comes, make sure that you acquire the data of name and what else I told, name and name and phone number. Okay, then after you collect, suppose you are doing a survey. So more, I remember during my university time, my PhD, during my PhD also, lot of veterinary students were there, and they were, sorry, lot of food scientists were there. So what they were doing is they were giving free milk, like to taste, so that I will reveal my allergic things, like whether I found the milk good or not, and that they will take a survey and keep it, and then based on the survey they will release to the market the best milk found by the customers. So they have 3 4 different types of milk. They will sell the milk which customer likes the most, so that they will get more profit. That's the idea. So this, Storing data is crucial, very much crucial. If you generate data but you don't store it, then gone, right? So the data storing in real life also is very difficult, isn't it? I mean, I don't know. Like in your computer, you have a lot of set of data. You download PDF files every day, okay, and your computer after 7 months gets full of data. Then you think what to delete, right, or transfer the data, right? So you should know how to store data and make sure that many data are related to privacy. Many data are related to privacy. I mean, many data are very sensitive. Make it password protected. Maybe in your bank account, online banking, when you download any document, you cannot open it. There is a particular password you have to type and you can open it. That is data privacy, data protection. Okay, and not anyone can open it. Only the one with a password can open it. Okay, use the data, of course. So how to use the data? Any ideas? How to use the data? Of course, this is more okay with the um, shopkeepers, right? They collect the customer data. Now it is up to them how to use it. If they collect the customer names and they did not even try to understand how many persons are male and how many persons are female, then what is the use? There is no use to unnecessarily collect and waste the time collecting the data. Okay, you should know which data to collect and how to use that data also. You cannot just collect the weight randomly, which is of no use. Okay, that's an extra attribute and just makes your algorithm slow down. Fine. How to share your data? How to share your data? There are some data which are meant to be shared. How, can you give me an example? If you remember that I don't want to point companies, but there are many soap advertisements or detergent advertisement which tells us that we remove 99.9 germs. Okay, yeah, we remove that percentage of germs, but might be technically true, might be how they are claiming it. That's the question. How they are claiming that? They must have made experimental results. They are experimental results. They must have taken a surface which is full dirty. They must have used the detergent and cleaned it. Later, through microscope and some analysis, they must have found that no bacteria or microbe is there after cleaning. Okay, maybe after 1-2 seconds or 5 seconds, within 10-20 seconds. After that, definitely microbes will come. So, in that area, no germs are found. Therefore, 99.9, and therefore people are buying it. That's the marketing strategy. So they are sharing that data, that they are sharing that the 99% of germs are killed. That 99.99% is the data. I mean to say, means it can kill the microbes. That's one of the idea. Is the example okay or too detailed? Is okay. You can tell me any other example if you will. I mean, you can share me the data also. Like, I think in your admission, when you took admission here, you saw the data of this university, maybe. Maybe many of you have seen the data, like how much percentage of students are getting placed. Out of 100 students, how much are getting placed? In SODS, how many students are getting placed out of how many students? Based on that factor, you decide, okay. And based on the number of courses also, how many courses, how many semester, okay, projects. These are the data being shared from the university side to the outside world. Okay, but there are some hidden data also which are not shared outside the society. Those are protected. Okay, I mean, your data, we cannot, university cannot share it to the public, isn't it? I mean, you understand? Okay, even if you go to any company, here, they won't reveal who is working with them. You will tell, can you give me how many persons, the detail of the person working in this company? What do you think? They will say, oh, yeah, yeah, we'll give. No, they won't give. Why they won't give? Because the persons working in the company are the asset to them. They know that if you are asking, you might take them away from the company. They might lose a workforce. The company might slow down. The company might make less profit. So sharing data can cause loss in some scenarios. While sharing data can create profit also in companies. Is it okay? Like examples? How many of you understood till now? At least store, use, and share. Is it clear for most of you or difficult? I mean, no. Sharing, it's up to you. How there is no algorithm for sharing. I mean, you can use platforms. For example, for university advertisement. I mean, I will tell a real example. How you share data? You are asking. Any algorithm? What's the algorithm? Definition of an algorithm. Oh, why here? I mean, I can tell you. I mean, if you have certain process, you have certain process to follow, and that you tell a computer to follow. So a computer cannot follow if you tell him like this, like you store this data column, okay, in the rainfall data and give the mean for every region. You do that. You cannot tell the computer like that. Now you can tell in this age, in this world, because GPT is there, it can read your voice data and get the keywords and write a code for you. But when GPT was not there, okay, you have to write an algorithm for it. How you will write an algorithm? For each region, I'll write here, for each region, okay, for each region in a particular set. This set will have all the regions, right? What you do, collect collect the data, then find the mean, okay, find the mean or median or mode. Then what you do with those mean, median, mode? Any ideas? Hmm? Yes, you kind of predict. Yeah, that is, you can do a lot of things. You can predict, or you can measure the standard deviation, right? You can measure the standard deviation and end, right? This is the kind of an algorithm. This you do for each region in a set W. This W is the world. W is the world set which has all the regions inside it. You do it for all the regions inside that world. So that's like an algorithm. But more about algorithms and all will be covered in your Python basic course. Okay, what is an algorithm? How you write an algorithm? So basically, you are telling a computer a process to follow, and a computer can follow the process based on an algorithm. Only computer understand algorithm. It cannot understand our language. If you tell do this, it can't understand. You have to write some for loops. You have to write some commands. Then only it can do. So that's the idea. No, we are not sharing the data set. Yes, yes. I mean, yes. After analyzing the data, you are just sharing a result. You are not sharing the data set. I mean, as an example, we discussed that. Yes, let us see an example. Suppose you go to an institution. This is an institution, and that institution, how you go based on the number of data, they don't reveal when you took admission. They did not reveal. They revealed how many students got placed. Okay, and this showed you some students, but did you get the data of all the students? Did you get the data of all the students? I don't think so. They did not give you a data set of all the students saying that yes, this student has been placed in this and this is the package. When he joined, when he did not join, all no. They just gave you a number, this many students got placed, finish. That is the outcome of the document. The placement document which they have created, that is the outcome of the document is some 70 students placed out of 100 students. That's it. So they don't share. By sharing, I don't mean share data set. I mean share the result. Okay. Sometimes sharing this result is also disadvantage. When I told you, which scenario I told you, when sharing data can be disadvantage. Yes, employees details. If you say that more of our employees have graduated from DUK, are working here, then what they will do? They got the idea. So they can easily check the student record in that year and contact those students and they can easily hire those people. They can easily hire those people. I hope it is clear that how sharing can be profitable and non-profitable also depending on the situation. Sometimes you have to destroy data. Sometimes you have to destroy data. Any examples when you have to destroy data? Always you store data, but there are scenarios where you want data to be destroyed. In movies, I can give you example of movies. Like, I don't remember which movie it is, but you see, whenever a investigator or a police guy comes, the villain, what he does, he puts the hard disk inside the oven and turns it on, and it burst, right? Why he did that? Because that hard disk had all the GB of data, TB of data, right? He doesn't want the data to be conveyed to the public, like very sensitive scientific information like nuclear data, okay, nuclear data sets, and those things cannot be revealed. So even though you do something like military actions, and those things cannot be revealed, those are very sensitive data which need to be protected, right? So if they cannot be protected, they will destroy it, but they won't let it go to wrong hands. That's the idea. I mean, that's an example I can share. Any other examples? Any other where you can destroy data sets? Even maybe an example can be like on your website, like a bank website or something, when you have data set of all the customers, when you have data set of all the customers who are taking the money, who have invested this amount of money, that can reveal the data set of persons funding, right? How much money they have, what is the balance of their account, and where they live, they can easily be found, they can threaten them. So those data set, if a bank cannot protect, he will delete it. So if a bank website gets hacked, the first thing they should do is delete those things, because they already should have a backup of that. So sometimes not only storing data is useful, but sometimes destroying data is that much amount of useful. Okay, is that much useful. So you should, and there is a proper strategy. So these are all the things. Uh, I mean, you can read. Okay, maybe I will share one website where you can read this data life cycle into much detail. Okay, but I have written a lot of things here. Build, acquire, you can see like acquire data set, that means data collection, ensure accurate and relevant high quality data. High quality data is received. Okay, it is not like maybe 20.5. What is your age? Maybe 21. No, exact, exact. If you say 20.5, okay, so you can see, was it on or okay? So you can see like data collection, high quality amount of data should be collected. Okay, and moreover, when you are collecting data set from different authorities and all, of course, some will not type. There will be some typing mistake. Okay, suppose someone is typing their age to be 21, instead of one, they're maybe pressing that shift button, so it is like this. Okay, so exclamation mark. So check on your keyboards that in one there is a exclamation mark also. So while clicking, might be exclamation mark can come. So this gives you an idea that it is indeed 21, but someone mistyped it. Okay, so you have to clean this data. You have to clean this data. This computer cannot recognize. Okay, and if you take mean of the ages, mean of those ages, then what will happen? It will not recognize it as a variable, numeric variable. Gone. So there will be error being thrown to you. Okay. So therefore, data cleaning is required, and we will spend some good amount of time in this data cleaning. Okay, there are various ways. Data imputation. I mean, if you see some data, missing data. Okay, suppose no one has filled their age. Suppose, then what you can do? You have to do the analysis, but due to that one row missing, you cannot do the mean and those things. So what you can do? Replace it with a mean of the ages of all the data set. You can replace it with the missing one, or you can do some analysis. That there are many types we will see, and we will see which one is the best one. Which one is the best one? So it will be the best if the distribution of the ages before the missing and after the missing is similar. You understood the idea? This is the logic. This is the logic I am trying to tell you. So suppose you have a missing element in the data set. Suppose in this class I collected age of all the boys and girls group, okay, and some would not prefer to disclose their age, and they did not write the age. But due to that missing age value, we cannot do any data analytics or analysis like mean or something. So we have to give a random something, right? Random value we can give. That is one way, okay. Else we can replace the age of, we'll take the mean of the age and we will replace the missing one with the mean. That is second way. Third way is there is a proper procedure. There is a proper procedure. Which age that we will learn. Now, there are four things. One is the original data set, random insertion, random imputation. Anything insertion in the data set, we call it imputation. Random imputation or the mean imputation, median imputation. You take the median of age and replace the median with the missing one. Okay, all these are there. Now, which one is the best, you think? Any ideas? We cannot say. I mean, suppose one of the persons here has taken a break, went to a job, and later thought that I should complete my masters and came back. Then, due to that age person, which has age around 35 or 37, it will affect all others because all others are in 21 or 23, 24 age, right? That will create a impact. That's like a skewed data. Due to one age group, it can get skewed. Okay. Now the fact is, the idea we cannot say. There is no general rule that this will be best. Okay. How we will say? Suppose you have the data set with missing data. You take the data distribution of the ages. You make a plot. This person is this age. This person is this age. You will get a plot. You will get a distribution. Yes. Now, after insertion of the value by mean, median, random, you should get a similar sort of distribution, isn't it? If you get a very different distribution, then it is not good, right? So this is the logic we will discuss later. I mean, it's for other classes to come. This is not the topic here. Fine. You have to format the data also, data formatting. Okay. Which format you want. Suppose year format. I will tell you there will be a year format, right? Maybe, can you give me an example in which year can be a data column? Hmm? Yes, exactly. Good. Date of birth. Yes, date of birth. All the students in this class, date of birth, right? So date of birth is there. Now, suppose in that column, date of birth is categorical. I told that date of birth will be categorical. Is it right or wrong? It's wrong. It cannot be categorical, right? Date of birth is numerical. 2000, 1998, 1999, these are numerical values. So if you store that variable as a categorical, it is wrong, and therefore you have to redefine that data as numerical, right? As an integer value, in fact, right? So therefore convert data to specific format. Data formatting. Okay, that's an example. Data verification. Verify the accuracy of the data which may affect the results of the analysis. Okay. I mean, suddenly someone, because of fun, maybe due to fun activities, when we do a survey, they will put the age as age. I'm telling age as this. Okay, age is this, which is of course not correct, right? 1985 means he has lived up to 1985 years. Okay, we can believe that it can be a date of birth, but it cannot be an age. Okay, so you have to verify the accuracy. Maybe sometimes people are very, hasty. They put year column into age and age into year column. So that thing can happen, right? So you have to verify the accuracy in those scenarios. That's what I meant by data verification. Fine. Data verification. Okay. Anyway, there are more other things. So I feel that uh, these things we can carry out in the next class. Okay. I mean, other parts of data lifecycle we can carry out in the next class. So many things, but I think I will share you a website. These are not that much important. Uh, most of the theories, but I'll see what to do. We can take it up after the break. Okay. So what I suggest is after the break, we will start with some of the coding sessions. Okay. We'll take a data set. Okay. Um, I will show you those things. Your job is to, we'll discuss after the class. Okay. So next final 1 hour of this class will be hands-on session. Like we will do something typing and all those things and see results, those things. Okay. Okay. So what we can do is maybe have a 10-minute break. Okay. We'll meet at 12.